Earthquakes are one of the most destructive natural forces on our planet, and as a geologist it's my job to try and understand them. I'm here in Greece following this dramatic earthquake fault line as it slices through the landscape. And on the way, I'm going to tell you 10 of the most remarkable earthquake stories from around the world. And there will be plenty of surprises along the way. So if you don't know how Cold War spying gave scientists a crucial clue to understanding earthquakes, where quakes last 60 times longer than anywhere on the planet, or which earthquake fault line causes hallucinations, then stay around as I reveal 10 things you didn't know about earthquakes. Earthquakes usually last for just a few seconds. And yet in those few seconds, they can cause destruction on a massive scale. Greece is the most active earthquake zone in Europe. So it's pretty bad luck then that it was also the birthplace of Western civilization. And that's the subject of my first story, the effect of earthquakes on our ancient heritage. Here in Greece, we're surrounded by the remnants of one of the greatest of all civilizations. Everywhere you look, you see the ruins of a world that's been lost to us. Of course, many of these magnificent buildings were destroyed by war and pillage, but an astonishing amount were destroyed by earthquakes. Even whole cities have all but vanished. The list is endless. The beautiful city of Helike on the coast, lost to an earthquake. The wonderful temple of Apollo at Corinth, destroyed by an earthquake. What must the ancient Greeks have thought when they saw their magnificent monuments shaken to destruction in a matter of seconds? How did they explain the terror of earthquakes? Well, not surprisingly, the ancient Greeks thought it was all down to the anger of the gods. They blamed Poseidon, Earthshaker and god of the sea, for all the carnage and ruin. But in the 4th century BC, the Greek philosopher Aristotle came up with one of the first rational explanations of how earthquakes happened. He thought that there were deep underground winds that caused the ground to fracture and shake. He may have been wrong, but at the time when every aspect of life was explained by the actions of the gods, this was at least a rational explanation. Today, we can explain most earthquakes through the theory of plate tectonics. The surface of our entire planet is made up of a number of moving plates. These tectonic plates fit together like giant pieces of a jigsaw puzzle. They sit on top of a hot, plasticky mantle of rock that's in constant motion. The cold, rigid plates move slowly over this hot, soft interior, just a couple of inches a year. But as they move, they grate and tug and get caught up with each other at the plate boundaries. And that's how earthquakes begin. You get a real sense of how plates move when you come up to a fault line like this. As the vast plates kind of slide past each other, they get snagged along their edges. When they get stuck, the pressure builds up along fault lines. Eventually, the strain gets so great that the fault ruptures, releasing huge amounts of energy, which shakes the ground for miles around. We measure that shaking on a scale of magnitude, sometimes called the Richter scale. Each number on the scale registers an earthquake 10 times larger than the last. So a magnitude 6 earthquake is 10 times larger than a 5, and an 8 is an earthquake 1,000 times larger.
Greece lies close to the edge of one of those plates, and what's probably one of the most geologically complex parts of our planet. That's why it's so earthquake prone. You can find dramatic earthquake fault lines like this all over the country.
It's no surprise then that so much of the ancient civilization that flourished here 2,000 years ago has disappeared forever. I wonder how different this country's architectural heritage would have been if it hadn't been in an earthquake zone. And what other unseen treasures from around the world have we lost to earthquakes? You don't often think about it, but if it weren't for the awesome destructive power of earthquakes, many of the greatest lost treasures from the ancients would still be with us today. Not just in Greece, but throughout the world. Earthquakes have dramatically changed our legacy from the past. My next story takes me back to the great San Francisco earthquake of 1906. This was one of the worst natural disasters in American history. But it was also a turning point for geologists because it led to a real breakthrough in our understanding of how earthquakes happen. 1906. San Francisco was a boomtown, the largest city in the American West, thanks to the Californian gold rush. But while its 400,000 inhabitants were chasing the American dream, they had no idea that the city was perched on one of the most unstable fault lines in the world, the San Andreas Fault. But on the 18th of April 1906, they discovered the horrible truth. An earthquake of magnitude 7.9 devastated San Francisco. The quake lasted for just 45 seconds, but that's all it took to destroy the city. Gas mains burst and fires burned out of control for 3 days. The earthquake and its aftermath left more than 200,000 homeless. This earthquake stunned everyone. Not even the scientists understood what had happened. In 1906, the study of earthquakes was still in its infancy. Very little was understood about how and why earthquakes occurred. But this was about to change. The scale of the devastation in San Francisco was so shocking that it stirred the scientific community into action. Our understanding of earthquakes was about to take a giant leap forward. Within a week of this event, a team of 9 scientists met for the first time, determined to revolutionise our understanding of earthquakes. First, they studied the way the ground had shifted throughout the area, and it was through this detailed analysis that they made the crucial link between the earthquake and the fact that the San Andreas Fault was somehow the cause. The San Andreas Fault is one of California's most distinctive natural landmarks, a gigantic gash across the state. We now know that this fault is where 2 massive tectonic plates meet, and they're slowly moving past each other all the time. But back in 1906, no one knew anything about these plates. Even so, the scientists did give us a lasting legacy that came from this study. One member of the team, Henry Fielding Reid, became fascinated by the way features like farm fences had been shoved out of line by the earthquake. The fences showed that the 2 sides of the fault line had shifted violently past each other in a consistent pattern. And from this simple observation, Reid came up with the first real theory about how earthquakes happen. Reid was the first person to work out that in some places the Earth's crust is being strained and stretched to breaking point. Until finally it snaps. And that's what an earthquake is. After this breakthrough, the whole study of earthquakes and geology took off and eventually revealed the secrets of how our planet works. So out of the ashes of the terrible San Francisco earthquake came the first glimmerings of scientific understanding about this terrifying force of nature. My next story is an intriguing tale about one of the eureka moments in earthquake science, though it reads rather like a Cold War spy plot. The 1960s was a time when America and the Soviet Union were locked in a nuclear arms race. And it was America's paranoia with secret Soviet nuclear testing that helped to prove one of the biggest theories in geology. So my next story is not an earthquake site, but a bomb site. This is Novaya Zemlya Island in Russia, one of the Soviet Union's secret nuclear test sites. The Soviets began testing their weapons in this remote place in 1954, at the height of the Cold War. Over a period of 35 years, hundreds of nuclear devices were detonated. But of course, the Americans were determined to find out exactly what the Russians were up to. And rather than send in their spies, the Americans came up with a brilliant plan. They decided to do some long-distance spying using seismometers. Seismometers are instruments that can register and measure shaking ground from thousands of miles away. So, in 1961, the United States installed 120 seismometers at sites all around the world, and soon they were recording every secret Soviet nuclear test. But all the time this network of seismometers was recording nuclear explosions, it was also monitoring the natural phenomenon that shakes the ground all over the world: earthquakes. And that earthquake data produced a major surprise for science back in the 60s. Earthquakes weren't scattered chaotically across the planet. They followed a narrow set of lines around the globe. In their search for nuclear explosions, they'd coincidentally created an accurate map of the world's earthquake zones. And what was the significance of this map? Well, the earthquake lines revealed the hidden edges of the Earth's tectonic plates. Now, in the 1960s, the theory of plate tectonics was a revolutionary new idea, but it was still just a theory. Now there was proof, because the seismometers were able to measure the direction the plates were moving in during an earthquake. For the first time, geologists had solid evidence that showed how all these plates were moving against each other at the fault lines and causing earthquakes. Who could have imagined that spying for nuclear secrets would end up providing key evidence for the most important geological theory ever developed: the theory of plate tectonics. My next story is about the deadliest earthquake in recorded history.
that happened in China in 1556. In a matter of seconds, this one earthquake killed nearly 1 million people. The reason it was so devastating is because in this particular region, people had always lived in man-made caves, and this would prove lethal in the earthquake.
The world's deadliest earthquake happened 4 centuries ago in central China, on a vast fertile plateau rising above the Yellow River. This is a region with freezing winters and baking hot summers, and the Chinese have come up with an ingenious solution to cope with these extremes of weather. Instead of building traditional houses, the locals have burrowed into the hillsides, creating caves or yaodongs. It's a tradition that goes back at least 2,000 years. Tunnelling through the soft soil to depths of hundreds of feet, these amazing structures are cool in the summer and warm in the winter. The fine silty soil here is easy to dig out to make caves, but that means it's also highly unstable and collapses easily. And it's this characteristic that proved to be so fatal in 1556. On the 23rd of January, a huge earthquake struck the region. Nearly 1 million people perished in this disaster, and it was the very structures they relied on for shelter that killed them. Their yaodongs collapsed like a pack of cards as the soft soil gave way under the huge shock waves, burying everyone inside them. The Shanxi earthquake may not have been the biggest ever recorded, but it was certainly the deadliest. And when you think that today, 40 million people still live in the same sort of caves as their ancestors, you realise that there could be much worse to come.
It's not earthquakes that kill people, buildings do. And the ancient Greeks were the first to try and design their buildings against earthquakes. Some of their temples had metal rods inserted in the columns. In our next story, we'll see how innovative building design can save lives. And it turns out, surprisingly, that one particular kind of skyscraper might be the safest place to be when an earthquake strikes.
Early in the morning of September 19th, 1985, Mexico City was struck by a massive earthquake. At a magnitude of 8.1, it was the worst earthquake in Mexico's history. At least 9,000 people died, with 30,000 injured. Despite the scale of the tragedy, there were some amazing miracles. 3 days after the quake, 58 newborn babies were pulled alive from the wreckage of a maternity ward. Rescuers continued to find survivors up to a week later. The greatest destruction happened in the area of an old lake bed. That's because when the shock waves hit the lake bed, something strange happened. The soft sediments under the buildings actually amplified the shock waves, making them far more destructive. These powerful waves cracked the foundations of buildings, setting up vibrations that shook them into rubble. So it's astonishing that it was in this very area of maximum destruction that developers decided to build the tallest building in Mexico, known as the Torre Mayor. It sounds crazy, but engineers were confident that in the Torre Mayor they could construct a building in this vulnerable place to withstand almost anything that nature could throw at it. Their first challenge was the foundations. Without solid foundations, this building could become an enormous glass and steel coffin, To get past the loose, marshy sediments of the lake bed and anchor the building in solid bedrock, engineers drilled down 200 feet. That's 3 times as deep as the foundations of the Empire State Building. Over 250 piles secured the main structure to solid ground. But what really helps the tower ride out an earthquake is an altogether different and unique piece of engineering. Behind the oceans of glass lies the strongest possible skeleton, a network of super-diagonal diamond braces. Where the super-diagonals overlap, they form 3 smaller diamonds. At each junction rests 4 huge shock absorbers. And this is how they work. The moment a seismic wave strikes the tower, giant pistons inside the shock absorbers are forced inward. These dampen the severe vibrations from the shock waves and absorb their energy. Instead of crashing to the ground, the tower flexes safely.
In the past, Mexico's been struck by massive earthquakes, 5 times more powerful than anything Torre Mayor has faced. Yet the impressive team of engineers that built the skyscraper are confident that it would survive an earthquake of that size. They believe that in one of the planet's worst earthquake zones, this could remain one of the world's safest buildings. Earthquakes usually last for a few seconds. Occasionally they go on for minutes. But there's one place where quakes can last for up to 1 hour. But no matter how long they last or how violent they are, these quakes pose no threat at all. The reason that you've never heard of them is that they're out of this world.
We have ignition sequence start. The engines are on.
My next earthquake story is all about our close encounter with the moon. On July the 16th, 1969, when Apollo 11 blasted off towards the moon, it wasn't just carrying a trio of astronauts. Apart from its valuable human cargo, Apollo 11 also carried a number of scientific instruments. What's extraordinary to realise now is that in these early flights to the moon, these science experiments were almost an afterthought. NASA scientists were so intent on simply getting the craft to the moon that they didn't give too much thought about what Buzz Aldrin and Neil Armstrong would do once they got there. So, in something of a rush, they put together instruments that would measure the moon's magnetic fields and investigate solar winds. But the one that interests me is a specially designed seismometer placed carefully on the moon's surface by Buzz Aldrin. These seismometers would one day reveal something totally unexpected about the moon. For 2 weeks, the seismometer made the first ever recordings of the moon's jolts and tremors. It even picked up the vibrations made by Buzz Aldrin climbing up the ladder into the lunar module. But that wasn't all. As more seismometers were sent up, the data sent back showed to everyone's amazement that the moon had thousands of quakes every year. Moonquakes. This came as a surprise to scientists because the moon has none of the geological features that cause earthquakes here on Earth. The moon is almost entirely solid rock. It has no tectonic plates rubbing up against each other. So what was the cause of these moonquakes? Well, they finally worked it out. And amazingly, many of these quakes, the really deep ones, are caused by the Earth. In just the same way that the moon's gravity pulls at our oceans, creating tides, planet Earth exerts a gravitational pull on the moon. Now, the moon doesn't have oceans or tides, but as the Earth pulls at its rocky structure, there's a build-up of strain as these rocks deform, and this strain is then released through moonquakes. And what came as a real surprise is that, unlike the short, sharp events we have on Earth, moonquakes can last for up to an hour or more. That's 60 times longer than most quakes on Earth. But it turns out there's a very simple reason for this.
Hey, Roger, detect personnel.
The Cornwall Valley, deadliest place on Earth. We're not ready for this.
This film is rated R.
When seismic waves travel through the Earth's crust, they die away pretty quickly. Even the biggest earthquake shakes the ground for just a couple of minutes. And that's because there's water on the Earth. And rather than acting like solid rock, the crust acts like a giant sponge, soaking up the energy of the seismic waves.
But the moon has no water on its surface, and when a moonquake strikes, it sets the whole sphere vibrating like a tuning fork. So that's why quakes last so long up there. There's no liquid to absorb the vibrations, so they just keep going and going. Just imagine the destruction an hour-long earthquake would produce in the average city here on Earth.
Of course, if we ever went to live in the moon, we'd have to make sure our houses were moonquake-proof.
That's one small step for man, one giant leap for mankind.
My next story couldn't be more different. It's about an earthquake fault that's destroyed empires and deposed kings. But not because of the violence of its shaking, but rather because of its extraordinary powers of prediction. This is Delphi, on the slopes of Mount Parnassus, the centre of the universe for the ancient Greeks. Here stood one of the most famous of all Greek temples, dedicated to the sun god Apollo. Built in the 7th century BC, this temple has a surprising dependence on earthquakes. For centuries, this was the site of the Delphi Oracle, the place to come if you wanted to ask Apollo what the future held in store. His answers came through the medium of a priestess known as the Pythia. She would enter into the temple's inner sanctum, a small enclosed basement chamber, sit on a 3-legged stool, and begin to issue prophecies to her paying customers. People came from all over the Mediterranean to ask if they'd be lucky in love or successful in war. Her answers determined the fate of people and nations. You're probably wondering what's the connection between earthquakes and prophecies. Well, Delphi actually sits on top of 2 intersecting earthquake faults. Geologists have recently found that these faults pass right through the inner sanctum where the Pythia was thought to have sat. Now, we know that some faults emit noxious and even hallucinogenic gases. And according to ancient writers, before going into a trance, the Pythia would drink from a spring running through the site. She would inhale intoxicating vapours from deep within the earth, vapours which would loosen her tongue. Geologists have found that water from a spring near the Delphi Oracle contains a gas called ethylene. This sweet-smelling gas is a narcotic. So when the Pythia went to her enclosed subterranean chamber to foresee the future, she could have been exposed to concentrations of ethylene coming out of the fault line strong enough to induce a trance. In other words, she was as high as a kite. It's thousands of years since people flocked to the oracle at Delphi to have their futures foretold. These days, we don't have to travel as far. You simply pick up a magazine and read your horoscope. My next earthquake is the most surprising of all, because it happened in a place that should never have had an earthquake. It's nowhere near an active earthquake zone. In fact, it's nowhere near a plate boundary. To find out more about it, I need to pop over to the land of reindeer. I'm here in Lapland, in northern Sweden, miles from any earthquake zone. So you'd think there'd be no earthquakes here at all. But you'd be completely wrong. I'm standing on the Parve Fault. Parve in the Lap language means wave, and when you look at it, you see it undulating away into the distance. And what's really impressive is its length. It may only be a low cliff, but it runs across the landscape for 90 miles, a great tear in the Earth's crust. There's only one thing that rips through the ground like this, and that's an earthquake.
What gets me about this earthquake, what makes it so surprising, is that it's so far from any active earthquake zone. The nearest one is in Iceland, over 1,500 kilometres back there. So, at first sight, it seems that this earthquake in northern Sweden is inexplicable. It shouldn't be here.
The height of this cliff, about 32 feet, also reveals the strength of the earthquake. It's been calculated that the one that caused this uplift of the ground must have had a magnitude of around 8.2. That's an unbelievably large earthquake in an area that's nowhere near a tectonic plate boundary. So what caused this mysterious earthquake? When geologists began to study the Parve Fault, they dated the earthquake event that thrust this cliff out of the ground at around 8,500 years ago. But while they had a date, they couldn't figure out the cause. And then it dawned on them. Something else had happened during this geological period. And that was the emergence of this entire region from the Ice Age. During the last Ice Age, this area was covered in ice to a depth of around 1.5 miles. That's about 3,000 tons of ice pressing down on every square foot of land. Or think of it this way, the weight of 2 Eiffel Towers pressing down on an area the size of a pool table. This exceptional weight of ice literally pushed the landmass down by many feet for thousands and thousands of years. And when all this ice melted, Earth's crust reacted in an unusually violent way. With the enormous weight of ice now suddenly lifted off the land, it began to spring up back to its original height.
Normally the land rises slowly and gradually, at about 1 centimetre or so a year, but not always. Sometimes, as the land is rebounding, stresses build up along a line of weakness in the rock until they reach such a point that an earthquake rips along and relieves the pressure.
We now believe that what happened in Norway and Sweden 8,500 years ago could happen again, and that's because of climate change. Some scientists believe that global warming could melt the ice caps that weigh down Antarctica and Greenland. And if that happens, the land will rebound, producing big earthquakes in the most unexpected of places.
Geologists know lots about earthquakes now, but surprisingly, even after decades of research, we still can't predict exactly when and where they'll happen. That's because the build-up of pressure deep inside the Earth is so slow and usually gives few warning signs that we can measure. But for some geologists, prediction remains the holy grail. And over in Turkey, there's one fault where we think we can make an earthquake forecast. We think we know exactly where the next earthquake will strike, and that's an exciting breakthrough. The only trouble is, we don't know when.
Here in Turkey, there's a fault line that slices through the country for 900 miles. It's one of the most treacherous faults on the planet. Millions of people live along its path. It's known as the North Anatolian Fault. Unlike most other faults, the North Anatolian Fault runs in a relatively straight, simple line, and that means it may be easier here for scientists to calculate where the next earthquake will happen. That's because scientists now know that after an earthquake, the stress from that one earthquake travels further down the same fault line and builds up in a new location along the fault. So in theory, if you can pinpoint where the stress has gone to after one earthquake, you know where the next earthquake will strike. The key is to work out where the stress from the last earthquake has travelled to. And one scientist, Jeffrey King, has been developing a computer model that can do just that. King and his team of scientists plot where all the aftershocks happen after a major earthquake. That tells you the broad areas where the stress is transferred to. But to pinpoint more precisely where the next earthquake might strike, this model analyses some key geological data about previous earthquakes. For instance, how deep underground the rupture was, the nature of the rocks in the area, and how much the fault had slipped. The calculations of where the stress had gone show up in red. To see if their model worked, in the 1990s, this team focused their attention on Turkey and fed all the geological data from the North Anatolian Fault into their computer model. Using this model, they then calculated exactly where earthquakes should happen along this particular fault line, according to how stress gets transferred. And they came up with 7 locations where they believed that earthquakes would happen, one after another, in a sequence running east to west. And then they compared these predictions with what had happened in the past. It was uncanny. They discovered that those 7 sites, running from east to west, were almost exactly where earthquakes had actually occurred, from 1939 to 1967. The model worked. So the question was, where did the model predict that the next quake would happen? In 1998, the team fed all the necessary equations into their computer and calculated where the stress would travel next along the North Anatolian Fault. The area that showed up red was the Bay of Izmit, home to 500,000 people. The scientists couldn't say when, but they were sure that an earthquake would strike Izmit. Newspapers and journals printed this remarkable news, but surprisingly, the warning barely registered, and life for the people of Izmit continued as normal. And then, just 1 year after they'd made their prediction, in August 1999, the scientists' forecast came true. The earthquake, measuring 7.4 in magnitude, lasted just 45 seconds. But that was enough to destroy much of the city and claim the lives of 25,000 people. But Izmit is not the end of the story. Everyone knows there will be another earthquake along this fault. Where next? Well, using the data from the Izmit quake, scientists have now calculated where the stress is transferred to along the fault line. The area they've pinpointed as the next earthquake site will be an area west of Izmit. It includes one of the greatest cities in the world, Istanbul. Scientists are sure that the earthquake that hits Istanbul will be as big or bigger than the one that hit Izmit. They're certain it will come, they just can't say when.
Being able to accurately forecast where an earthquake will happen is a major breakthrough. But even if we could take it a step further and predict the exact time and place, how can you evacuate a city of 10 million people in just a few days? It would be practically impossible. And that brings me to my final story. The story of the most powerful and violent kind of earthquakes that can happen on Earth. They're called megathrust earthquakes. This particular story is about one coast where a megathrust earthquake happened in the past and where we know one will happen again.
The people of California live under a terrible shadow. They know that one day the San Andreas Fault will rupture, unleashing an enormous earthquake. But all this time, an even more powerful hazard lies just a little further north. It's a completely different fault, and it's going to unleash an earthquake up to 30 times more devastating than anything the San Andreas Fault can produce. The source of all this danger lies deep beneath the waters of the Pacific Northwest coast. It's a huge gash in the Earth's crust that's hundreds of miles long. It runs from British Columbia in Canada and ends in Northern California. It's called the Cascadia Fault. The Cascadia Fault lies on what geologists call a subduction zone. A subduction zone is where two giant plates meet head to head, and one of them gets pushed right down under the other. Subduction zones can produce the biggest earthquakes on the planet. Subduction zones cause earthquakes when the plate that's being pushed down gets stuck. As it pushes, the upper plate gets squeezed and distorted. Eventually the strain becomes too much. The upper plate slips, and that's what creates a rare event. A megathrust earthquake. The power of an earthquake depends on the size of the fault that breaks. And there's something unique about subduction zone earthquake faults. With most earthquakes, only one small part of a fault line shifts, the part that's snagged. The section that breaks can cause violent shaking and devastation in the immediate area. But when a subduction fault ruptures, something quite different happens. It can unzip along the entire length of the fault line for hundreds of miles. The effect goes way beyond the reach of any normal earthquake event. The Cascadia subduction zone is almost 700 miles long. If it does rupture along its full length, then scientists believe the next Cascadia earthquake will be one of the largest ever recorded, a magnitude 9 or greater. That's a terrifying prospect for the people of the Pacific region. When the Cascadia Fault ruptures, the shock waves will fan out across the whole northwest coast of the continent. And lying directly in its path are major cities like Vancouver, Seattle and Portland. But it's not just its power that would be so devastating. As the fault ruptures, it will unzip at 6,000 miles per hour. Even at that speed, it will take 5 minutes to travel the entire length of the fault line. A 5-minute earthquake is far longer than normal. And the big question is, when will it happen? Forecasting earthquakes is notoriously difficult, and no one can say when Cascadia will rupture again. But it's possible to look back at the geological record and see how frequently they've happened in the past. Sure enough, the Washington coast does hold traces of several past megathrust earthquakes. So when will it happen next? You can calculate that according to when it last ruptured. And according to the geological record, the last time that happened was in 1700. That's 300 years ago, and in the past, it has ruptured at roughly 300-year intervals. So the next Cascadia earthquake could be just around the corner. We just don't know. And for the people of the Pacific coast, that's a pretty troubling thought to live with.
It seems to me that earthquakes will always bring devastation to our planet. We certainly can't prevent them. We still can't even predict them.